Hello everyone, today me and my friend Syaahid are going to talk about progression. Now what is progression? Progression is a sequence of numbers that is arranged in either ascending or descending order. And secondly, in a progression, a pattern is identified. What do I mean by that? For example, let's say in number 2, 4, 6, right? It is a progression, I say. Why? Because first of all, it is a sequence of numbers that is arranged in ascending order, because the value of each number gets higher every time. And then secondly, a pattern is identified. We can see the pattern here. To get the second term from the first term, we add 2 to the previous term, and then to get the third term, we add 2 to the previous term. So that is the pattern that we identify. And then in Form 4, we learned about 2 types of progression, which are arithmetic and geometric. Now, me and my friend are going to talk about arithmetic progression, while my other friends are going to talk about geometric progression. The difference between these two is that arithmetic progression is a sequence of numbers such that each term is obtained by adding a constant or common difference to the term before it. This constant is called common difference. Okay. So what is a common difference? Before we move on to getting to know what is common difference, we first need to know about terms. So in every sequence, there are terms. So let's take a look at this sequence 2, 4, 6, 8, right? The first term is 2. So because it is the first number in that sequence, so first term is 2, the second term is 4, and the fourth term is 8, because 8 is the fourth number in that sequence. Now T1, or the first term, is also known as A, and this will be very useful when we will learn about a derivation of formula later on. Now let's get to common difference. Common difference is a constant, so D is the symbol for common difference, that is added to a term, nth term. So it can be first, second, third, or whatever term in that sequence, to get the next term, T n plus 1. So the nth term plus 1. So for example, if you want to find the common difference, we'll use this formula: D equals to T nth term plus 1 minus nth term. So let's say let's look at this example, 5, 10, 15, and 20, right? So let's say we want to use n as first term. So if n is the first term, so n equals to T1, the first term, right? If n is 1, so Tn plus 1 equals to T1 plus 1 equals to T second term. So in order to get D, we'll use the second term minus the first term. Second term is 10, so D equals to second term minus first term equals to 5. Now, to make sure it's really an arithmetic progression, we can use whatever term, right, as I said before. So let's say we want to say n equals to the third term. So D equals to T3 plus 1 minus T3. So D equals to T4 minus T3. Now let's substitute the number. D equals to 20 minus 15, the fourth term minus the third term. And then lastly, we will get D equals to 5. Now this is what I meant by common difference, because the difference between each term is the same, it's common. Now when you get these two common difference, then only then you can prove that it is an arithmetic progression. So in whatever sequence you see, you can only determine whether it is an arithmetic progression or not if the sequence of numbers has at least 3 terms. So if it has 2 terms, then we cannot determine whether it is an arithmetic progression or not, because there's only one difference, so you cannot find the common difference. Now let's take a look at some exercises I've prepared for you all. For question number 1, tick the sequence of numbers which is an arithmetic progression. How do we know if a sequence is an arithmetic progression? Well, first of all, there must be a common difference. What is a common difference? A common difference is that the difference between each pair of terms is the same. So in A, for example, there's 3 difference, right? D3, D2 and D1. D3 is T4 minus T3, D2 is T3 minus T2, D1 is T2 minus T1. 8 minus 6, 6 minus 4, and 4 minus 2. And all of this is equal to 2. So we can conclude that D1 is equal to D2 and D2 is equal to D3. So the difference between each pair of terms is the same, therefore there is a common difference, and it is called an arithmetic progression. Now let's take a look at B. The same method that we used before, only that now it involves algebra. So since there's 3 terms, there's only 2 difference, D1 and D2. D1 equals to the second term minus the first term, D2 equals to minus the first term. So D2 equals to the third term minus the second term. D2 minus D1 equals to M plus 2 minus M equals to 2. Right? And then for D3 minus D2, it's M plus 3 minus M plus 2. So M plus 3 minus M minus 2 equals to 1. D1 equals to 2. Right. While D2 equals to 1. And we can conclude that D1 does not equals to D2, therefore it doesn't have a common difference, and thus it is not an arithmetic progression. Now let's take a look at C. 12, 14 and 12. There's 3 terms, so there's only 2 difference, D1 and D2. D1 is D2, T2 minus T1, D2 is T3 minus T2. So 14 minus 12, and then 12 minus 14. 14 minus 12 equals to 2, while 12 minus 14 equals to negative 2. D1 equals to 2, D2 equals to negative 2. We can conclude that D1 does not equal to D2, so there is no common difference. Therefore, it is not an arithmetic progression. Lastly, let's take a look at question number 2. Azul and Jonathan are placing national flags along the school corridor from the canteen to the staff room. The distance between the first and second flag is 5 meters. First and second flag is 5 meters. The third flag is placed 10 meters from the first flag, and this is the pattern of arrangement for the rest of the flags until the end. So there's a third flag, and it is 10 meters from the first one, which means that it's also 5 meters from the second one. Determine whether the arrangement of this flag follow arithmetic progression. Give justification for your answer. So it's just like what we did before. There's 3 terms or 3 flags in this case. In order to find out whether it is an arithmetic progression, we need to find the difference and determine whether it is a common difference or just difference. So D1 equals to T2 minus T1, while D2 equals to T3 minus T2. 5 equals to 5. We can conclude that D1 equals to D2, therefore it is a common difference, and the arrangement of flags follow arithmetic progression.
Sure, that 1 to T1, T2, T3 tu saya rasa T1, T2, T3, that one flag 3 betul ke tak?
Yeah, F1 is the flag 1, flag 2, yeah. Now my friend Syaahid are going to talk about a few more questions.
Assalamualaikum. Let's see the question. Find the common difference D for each of the following arithmetic progression. The first question, negative 35, negative 21, negative 7. And the second question, log 2 base A log 2 power of 4 base A, log 2 power of 7 base A. So, as we know, the formula to find the common difference is D is equal to T2 minus T1, or D is equal to T3 minus T2 is the same. Let's see the first question. Negative 35, negative 21, negative 7. Firstly, we identify the T1, T2 and T3. As we know, D is equal to T2 minus T1. So we derive the formula D is equal to T2 minus T1 equal to negative 21 minus negative 35, and the answer D is equal to 14. So let's see the second question. Log 2 base A, log 2 power of 4 base A, and log 2 power of 7 base A. So we identify the T1, the T2 and T3. So we use the other one, which is D is equal to T3 minus T2. So it will be log 2 power of 7 base A minus with log 2 power of 4 base A. So we use power law to change the form. So it will be 7 log 2 base A minus with 4 log 2 base A. And the answer we will get D is equal to 3 log 2 base A. So let's see the other form of question. Complete the network diagram below. Given that the relationship of the following network is a consecutive term in an arithmetic progression. So let's see the first question. In this case, we need to find the common difference first, and we need to have two terms in a line, like 10 and 8. So T3 minus T1 is equal to 2D, and 2D we divide by 2 and we will get the D, which is the common difference. So 10 minus 8 divide by 2 and we will get the common difference equal to 1, and the common difference we add back with the previous term, which is 8, and we will get the answer 9. Next, 9 minus 5 is equal to 4, which is the common difference, and then the common difference we add back with the previous term, which is 9, and then we will get the answer 13. So next question, it's also the same. We need to find the common difference first, and then we need to have two terms in a line. So T3 minus T1 is equal to 2D, and 2D divided by 2 equal to common difference D. So 12P minus 2P divided by 2, we will get 5P, which is the common difference, and then 5P we add back with the previous term and we will get 7P. So next, we also need two terms in a line, like 7P and negative P. So 7P minus negative P divided by 2 and we will get 4P, which is the common difference, and then 4P we add back with the previous term, which is negative P, and we will get 3P. So last, 2P minus 3P is equal to negative P, which is the common difference, and then the common difference, which is negative P, we add back with the previous term, which is 2P. So negative P plus 2P is equal to P.
Arithmetic progression, you have a series of number, okay, and it has pattern, okay, meaning that the difference between two consecutive terms are the same, okay. So kalau consecutive means for T2 dengan T1 kan, kalau T3 dengan T2, T5, T6 macam tu lah, and then the difference, okay, the difference between the two consecutive are the same. Then you say that the series is an arithmetic progression macam tu. And you must know that T1 tu first term, T2 is second term, term tu tau, term, okay. And we symbol the first term as SA SA. Okay, lepas tu kalau macam you nak T tu the nth term. Okay, Tn is the nth term. Okay, kalau ada T n plus 1 means a term after Tn. Kalau T n minus 1 a term before Tn. That one is yang ni macam overall for the whole chapter progression, because in this chapter you're gonna learn arithmetic and geometry.